Good morning, everybody. So, as we know, till now we studied discovery of electrons and as well as discovery of protons. Same way, how it has been done and who has been discovered. And same, we have studied the three atomic models. One is proposed by Mr. J.J. Thomson. Second one is by Mr. Rutherford. And the third model is proposed by whom, guys? Bohr. So Bohr's atomic model. So now if it comes also same way, we studied the limitations of J.J. Thomson model, same way Rutherford atomic model and as well as Bohr's model. Now till this Bohr's atomic model, only the people knows about two subatomic particles of the atom. That is what? One is about electrons, which is discovered by whom, guys? Electrons is discovered by anyone? Mr. JJ?
And Goldstein.
Electrons I'm asking.
J.J. Thomson, sir.
J.J. Thomson. So electrons has been discovered by Mr. J.J. Thomson, and same way Mr. Protons has been discovered by Mr. Goldstein. After this, so many years after, approximately around 1927, so it has been one more third subatomic particle has been discovered. That is what we used to call as neutron, which is done by Mr. Chadwick. So these are the three important general awareness questions also. So which is what is discovered by whom. So now let us discuss how this neutron has been discovered and who has been discovered at all. So it was assumed in 1920 that there are only electrons and protons present in an atom, but the mass of atom is only due to the protons, as the mass of electrons was negligible. Yes or no, guys? So people used to believe that only whatever the mass of atom is present, only due to the whom? Only because of protons. Because mass of electrons is what? Mass of electrons is negligible. Why it is negligible? We all people knows that because mass of one electron is 1 by 1840 times less than mass of proton. So that is what it is. So extremely small. So that is why people used to believe that whatever the mass having by the atom is only because of protons. But later, in the year of 1932, you can see here approximately how much difference. Mr. James Chadwick, he has been discovered a third subatomic particle. He's actually an English scientist who discovered this third subatomic particle that is only called as neutron. So how he has been discovered? Let us discuss everything. So when this during this 1932, Mr. Chadwick bombarded means collision, guys. Please remember that. He bombarded beryllium foil with alpha particles. Rutherford bombarded with what, guys? Alpha particles with whom? Everybody. Alpha particles with which foil? Gold foil. That is what? Rutherford experiment. So Rutherford experiment leads to find what? Anyone? Leads to find nucleus. Nucleus. That is what? For this only, for discovery of nucleus only, he has been awarded with the Nobel Prize in the year of 1908. Now, Mr. Chadwick, to find the neutrons, what he has done, he bombarded beryllium foil. Please, all of you remember that. Beryllium foil with alpha particle. Who is alpha particle? Anyone? Mr. Danishkar? Who is alpha particles?
Nuclei of helium ions.
Yes. Nucleus of helium, helium He2 plus ions. That is what it is. Electrons is removed from helium. That is what alpha particles will say. So he observed when he is hitting or bombarding this beryllium foil with these alpha particles, he observed that a chargeless particles are coming out. chargeless particles having 1 AMU. What do you mean by AMU, everybody?
Atomic mass unit.
Mass unit. So he found that when he is hitting this beryllium foil with alpha particle, chargeless particles are coming out and their mass is 1 AMU. So later on, he confirmed that these chargeless particles only, chargeless particles only, called as what? Anybody? What he used to call? Is to called as neutrons. That is how the discovery of neutrons has been taking place. That equation also I'll give you. So he bombarded beryllium foil. This is what the beryllium actually. Please learn it. Beryllium is hitting with the helium particles, He alpha particles. That is what He2 plus alpha particles, so that he noticed it. Okay, so a positively charged, first I'm writing something carbon plus, he has noticed that a 1 AMU of, here you can see that 1 AMU of neutron is coming. So that is what is the chemical, like we can say, equation to represent neutrons are evolving when we are hitting the beryllium foil with the alpha particles. That is the equation, that is the reaction has been noticed by Mr. Chadwick. So neutrons are the neutral particles, does not have any charge. You can see no charge is there, only they have mass. What is the mass of one neutron? Anybody? Yes, please. Mass of one neutron, how much they have been found? Approximately it is equals to 1 AMU. Understanding? So that is what. And later it has been found mass of one proton. Mass of one proton, which is equals to mass of one neutron, approximately. So that is why we will consider mass number. We will study in the later classes. What do you mean by mass number means, which is equals to, what is that, guys? Mass of proton, sorry, number of protons plus number of, mass number means what? Number of protons plus number of neutrons. Both is called as mass number, because one proton mass is approximately equals to one neutron mass. That is what you have to remember. So that is why, so these neutrons, as we know, they are neutrally charged particles, does not possess any charge. So that is why we can say neutrons are represented by simply N. No charge is present above it. So that is what you have to remember. Now, for example, let us take example, if you have taken carbon. So can you tell me what is a carbon? Carbon atomic mass, anybody? Let me see who will say carbon atomic mass. All of you?
12.
12. Very good. So carbon atomic mass is 12 U or 12 AMU. But if you have taken, what is the number of protons? Protons is what? Only protons, how many? Number of protons. Anyone? Protons are present, how many? Only present 6. But atomic mass is what? 12. How? Because it is having, as we all know, atomic number. All of you remember, atomic number means we will take only number of protons. Okay? Number of protons, or we will take number of electrons also. Because if for every atom, if you have taken every atom, number of protons is equals to number of electrons. Okay, that is what atomic number we will say. But atomic mass, number of neutrons may varies. It is not always equals to protons. But if you have taken in the case of carbon, number of protons are 6. So remaining 6 are there. So what is that? Atomic mass. Number of neutrons also. How many are there, guys? Anybody? 6. That is what it is, 6. So 6 plus 6 only, we are getting 12 units. That is how the neutrons will having also 6. So that is why atomic mass of carbon is 12 units. So if there is no neutrons, what is atomic mass of carbon? Anybody can tell? If there is no neutron. Yes, please.
6U, sir.
6U only. Understanding? So after discovery of neutrons only, it is explained that the extra 6 units of mass is because of whom, guys? Is because of neutrons. That is what you have to remember. Now, 2 statements I will say you. Please write that 2 statements. In any atom, write it. In any atom, number of protons is equals to number of electrons. In any atom, number of protons is equals to number of electrons. Number of protons is equals to number of electrons. But number of protons but number of neutrons may or may not be equal. May or may not be equal. Are you clear, everybody? All of you? Yes, please.
Sir, once again, can you see the sentence?
Yeah. In any atom, number of protons is always equals to number of electrons. Number of electrons. In any atom, number of protons is always equals to number of electrons. But number of protons and number of neutrons may or may not be equal. May or may not be equal. Clear?
Yes, sir.
Completed? So now carbon, if you have taken carbon 12, we will say basically. So carbon is having 6 protons. Of course, here number of neutrons also may equal. But if you have taken carbon, another kind of carbon will be there. We'll study it. Is called as isomers. So sorry, isobars we can say. So now if you have taken, it is carbon 14 we will say. So carbon 14 means, so its atomic mass is 14. Means in the sense of number of protons, anybody can tell me? Number of protons remains constant. That is how many? 6 only.
Sir.
But number of neutrons, how many is become now? Anyone?
8.
That is what you have to remember it. So for example, if we'll take sodium 23 is the atomic mass. So it is having only 11 protons. Means in the sense of neutrons are how many remaining? 12 neutrons are there. Clear? So that number of protons and electrons may always equal for a given atom. But who is not equal? All of you. May or may not equal. That is what we will say. It is neutrons. So isotopes we will get it by the time we'll study. Isotopes by the time I'll teach you that. What is clearly that. Clear? So now this is what about discovery of neutrons. So discovery of neutrons, he bombarded alpha particles with a beryllium foil. So during that he noticed that no uncharged one AMU mass, one atomic mass particles are coming out. So that is what he called as neutrons. Now, let us study the theory behind why was the neutrons discovered late. That is what the question now. So that is the explanation also I will give you. So why was the neutron discovered late? So if you have consider, so neutrons could not be discovered earlier because they cannot be deflected by any magnetic field. Do you understand it? So if you have taken electrons and protons, they are having some charge, so that either they will be attracted or they will be moving far away from the electric field or magnetic field. I taught you the properties of electrons. That is what Canal rays, and as well as that is what we can say negative rays. What is that rays? I forget it. Electron,
Cathode rays.
cathode rays and anode rays. So they are showing the deflection towards the magnetic field. Understanding why? Because they are having some charge. So if it comes to the neutrons, as they don't have any kind of charge, so that is the main reason why it cannot be discovered. Okay, so it has taken time to discover because it is not showing the deflection. It is not deflected in an electric field. Because why? They don't have any kind of charge. So people and also believes that initial case, the entire mass of the atom is only because of whom? Mr. Danishkar, Sanjay, people used to believe that it is only what? The mass of an atom is due to the only protons. But later only they noticed that number of protons and the mass of the atom is different. So that is why later only the neutrons has been discovered. Because before they used to consider hydrogen atom. So if you have taken hydrogen, basic hydrogen, what is the mass of hydrogen? Anybody can tell? Atomic mass. Atomic mass of hydrogen. All of you. 1U. Understanding? Because it has only one proton. Only one proton. No neutron is present. No neutron is present. Okay. So that is why people used to believe the mass of atom is only because of what? Only because of protons. Are you understanding? So that is what you have to remember. And if you have taken helium, how many protons? All of you? How many protons? 2 protons. So they consider mass of helium should be 2 times the mass of hydrogen. But actually it is how many times? Actually is how many times? Mass of helium. Yes, please. How many times?
4 times.
4 times it is bigger. So people used to believe actually hydrogen mass is 1U, and they have considered helium contains 2 protons. So people thought that helium is having a mass of 2 AMU. So this is expected one. But what is the reality? How many times it is? Yes, please. How many times it is? 4 times. So then only that doubt came, and it was suspected by not Mr. Chadwick. It is Rutherford itself suspected. So he suspected that something is there in the neutral. That is what some other uncharged particle is present in the nucleus. That is how, after the discovery of neutron by Mr. Chadwick, so it was confirmed that a nucleus only contains both protons and as well as neutrons. Just actually he suspected, Rutherford suspected that some other may be present in the in the nucleus. That is what uncharged particle, but he has not proved. So later this Chadwick has been confirmed. So then only it has been proved that in nucleus both protons and neutrons are present, and the electrons are revolving around this nucleus in a particular orbits. So that is what the atom model has been made into seeing. So we have been considered that electrons has been revolving around the nucleus in a particular orbit, and nucleus contains both protons as well as neutrons. So, but if you have taken hydrogen, if you have taken basic hydrogen, it does not have any kind of neutrons in its nucleus. Only it has what? Only it has what?
Proton.
Only one proton. So that is what people used to believe, and they thought that everything like only protons are present. But later only mass is not same, so that they identified it. So remember, it if you take hydrogen, it has only one proton and one electron, which is revolving around the nucleus. But others, everything other than basic hydrogen, if you take any kind of atom, helium, 2 protons and 2 neutrons, like that, everything. If you have taken carbon, 6 protons and 6 neutrons. If you have taken oxygen, 8 protons and 8 neutrons, like that. Every atoms, they contains some unknown uncharged particles also. So that is what we used to call as neutrons. That is what discovered by Mr. Chadwick. Okay, so he's Mr. James Chadwick. He is the one who born in England. Actually, he's an England physicist basically. So he has even he is even a way towards a fission of uranium. You might be knows one of the nuclear metal will use a nuclear reaction. He's also very greatest scientist. He has been even made this atomic bomb also. He is one of the one who is also involving this uranium bomb, uranium 235 atomic bomb. Okay, so for this discovery only, he has been even awarded with the Hugo's Medal and the Royal Society in 1932, and also Nobel Prize winner in 1935. He is also a Nobel Prize winner. Please all of you remember that. Okay. So during the 1935, for this discovery of neutrons, he proved the existence of neutrons. So that is why he has been awarded Nobel Prize in 1935. And he also worked the way towards the fission of uranium 235 in atomic bombs. So that is the reason he has been awarded Nobel Prize in 1935. Finally, he has been passed away in 1974. 1974 means it's not very far. When we understand 1974, it's like recent years only we can consider, just around 50 years before. So that is what it is about Mr. Chadwick, James Chadwick. He's also one of the great physicist of England, actually. So now this is all about discovery of electrons, discovery of protons, discovery of neutrons. Now let us study properties of neutrons. Have you understood, everybody? Clear? Please respond. Properties of neutrons. Keep reading. First thing, neutrons are neutral subatomic particles. Neutrons are, Omar, understand, Omar? Neutral subatomic particles as they do not carry any electric charge. Next, the absolute mass of neutron is, as I told you, mass of neutron is equals to whom, guys? Mass of neutron is equals to whom? Approximately mass of?
Sir, can you hear me?
Proton.
Yeah, mass of proton. Okay, so that is why we'll consider mass of proton and mass of neutron is almost same. That is what you have to remember. The absolute mass of neutron is 1.67 into 10 power minus 24 grams. Yes, Omar. 24 gram, which is equal to the whom, Mitakshri? Equal to the mass of proton.
Proton, sir.
Okay, that is why we'll say, okay, relative mass is approximately equals to relative mass of neutron is approximately equals to how many units, guys? That is AMUs is 1 U or 1 AMU. That is what you have to remember. Anyone having anything doubt, you can ask. Okay, so this is all about discovery of electrons, discovery of neutrons, and discovery of protons. The scientist names and all, please learn. It will be definitely will come. So till here, you will surely going to get in our exam also. Surely going to get so many questions related to this. Shruti, understand? Shruti, Tejaswini, Aswin,
Yes, sir.
anything doubt? Anyone can ask me. So if you understood this, so first mainly concentrate on Rutherford model. So Rutherford model is very, very important. What is his observations? What is his conclusions? And what is his drawbacks? That is what is very, very important. So please learn that. So after that only you can concentrate on J.J. Thomson model as well as discovery of neutrons by Mr. James Chadwick. So please learn everything without fail. Okay. So now, if you have done this, then we are going to study the next concept. That is what we will call as atomic number. So please all of you keep waiting. Atomic number. Is it completed?
Yes, sir.
Yes, sir.
Keep waiting next. Atomic number. Okay. So atomic number means, remember all of you, atomic number of any element is equals to only number of protons present in the nucleus of the atom. So all of you remember atomic number means immediately you have to remember the symbol of atomic number will represent with the what? What is atomic number symbol? Z.
Z.
Okay. So now what do you mean by atomic number? Means all of you remember, not even don't remember that about the electrons also. Only remember atomic number means number of protons. That's all. Okay. But every atom, number of protons is equals to what? I told you, number of protons is equals to what? Somebody. Number of
Electrons.
number of
Electron.
electrons. So I can say any atom, as we know, atoms are electrically neutral. Number of protons is equals to number of electrons. So atomic number means I can say number of protons are is equals to number of electrons also. But we people will consider only number of protons because electrons may loss or gain by the atom and they will turns into ions. But who is always remains constant? Everybody, who is remains constant?
Proton.
Is protons. That is why atomic number means only will consider number of protons present in the nucleus of an atom. That is what is called as atomic number, right? The atomic number of an element is equal to the number of protons present in the nucleus of an atom. That is what we used to call as atomic number. Okay, so this also right, but of course atomic number means you can write number of electrons also. You can mostly will consider only protons only. Please remember that. Clear, everybody?
Yes, sir.
Yes, sir.
Now, so one more interesting fact also I want to say. Now, whatever we are studying this atomic model, you can see that you might be remember already have written in our NCERT book also. We're drawing hydrogen, oxygen, like that. First 20 elements they have given the atomic structures. Is it yes or no? I think 18 elements they have given. Correct? Yes, please.
Yes, sir.
So this 18 elements. So who has been the first scientist introduced this atomic model? He a scientist name called as Schrodinger. He is a scientist who has been given a revolutionary change in the atomic model, and he proposed that electrons do not orbit the nucleus but behaves more like waves traveling at a fixed distance with the fixed energies around the nucleus. So that is what whatever the model we are studying today, they are traveling around the nucleus with the fixed energies and a fixed distance from the nucleus. This is one who has been given by Australian physicist called as Irwin Schrodinger. You will get in 11th class Schrodinger equations. By the time you'll understand, we'll calculate the energy also. So Irwin Schrodinger, he is the one who is introduced the atomic model, the present atomic model, what we are studying in general awareness. Okay. Now let us comes to here atomic number. So in 1913, a scientist named called as Moseley, 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 he worked on determining the exact positive charge in the nucleus of an atom and gave an important parameter that is only called as, what is that important parameter? Anybody? Yes, please. That is only given by whom? Atomic number, which is given by Mr. Moseley. So when he is doing the research on exact amount of positive charge in the nucleus, then only he given this concept called as atomic number. And for example, if you have taken, let me take aluminium. So how many of you know aluminium? What is the symbol of aluminium? Yes, please. Al.
AL, sir.
And its atomic number is 13. So He found that because the number of protons in aluminum, how many guys? Number of protons in aluminum is how many? 13. And number of electrons also 13 only. So that is how when he is doing the research on